This next problem concerns the calculation of the probability that x is between mu minus 2 sigma and mu plus 2 sigma if x is either Poisson with parameter 5, exponential with parameter 3, and this is a misprint, should be exponential with parameter 5, or else normal with parameters 16 and 3. So let's do this. First off, if x is Poisson with parameter 5, then from the formulas, we know that the expected value of x is equal to 5, and the standard deviation of x is equal to the square root of 5. So the probability in question here is going to be the probability that x is somewhere between 5 minus 2 square root of 5 and 5 plus 2 square root of 5. And so that's equal to the probability that x is somewhere between 0.5279 and 9.4721. Now this is a little bit silly because x is Poisson, which means x can only assume integer values. So x can only assume integer values. If x is between these two marks, that means x has to be between 1 and 9 some places. It could be 1, 2, 3, 4, 5, 6, 7, 8, or 9, because those are the only integers between these two decimals. Now it's Poisson with parameter 5, and so this will be equal to e to the minus 5 times 5 to the first over 1 factorial, plus e to the minus 5 times 5 to the second over 2 factorial, and so on until e to the minus 5 times 5 to the ninth over 9 factorial. And then there's no shortcut, we just simply have to add them up and see what we get, and the result that we get is approximately 0.96143. So that is the solution of this one. Number 2. Suppose exponential with parameter 5. That's a misprint here. I'll correct that for the spreadsheet, or for the review sheet. So if x is exponential with parameter 5, then we know that the expected value of x and the standard deviation of x are both equal to 1/5. And so the probability question is the probability that mu minus 2 sigma less than or equal to x less than or equal to mu plus 2 sigma. That's going to be the probability that x is somewhere between negative 1/5 and 3/5. And I miswrote this. Technically, there's a less than sign here. Here I have less than or equal to. Technically, that's incorrect. But this is a probability density function, and so the equal sign does not matter because it's going to be the same integral whether it's a less than or equal to or also less than. Okay, now let's figure this out. Now this will be the integral. Now it's not going to be from negative 1/5 to 3/5. And it's not that because we know full well that x is exponential, which means that it only has positive answers, or positive values. And so it'll be from 0 to 3/5 because x is exponential, the only possible values are positive. Then we integrate 5 e to the minus 5x dx. And so that is equal to e to the minus 5x from 3/5 to 0. So that's negative e to the minus 3 plus 1, which is approximately equal to 0.59021. So that is the solution if it's exponential. For part C, or part 3, suppose that x is now normal with parameters mean 16 and standard deviation 3. Then the question is the probability that if I take 16 minus 6, that's 10. And then 16 plus 2 times 3 is 22. Then I use the standard technique of converting this to a standard normal random variable. So that'll be 10 minus 16 over 3, less than or equal to 22 minus 16 over 3, which is the probability that z is between negative 2 and plus 2. And then from this point we use the normal table, or else use technology, and this works out to be approximately 0.95021. And I'll let you think about this, but it doesn't matter what these numbers are. This could be any mean, this could be any standard deviation, and when I compute this probability, it will be the exact same thing, negative 0.95021. That's a property of the normal distribution, and that's not true of the previous two problems involving the Poisson and the exponential. You can have any two numbers here you wish, as long as sigma is positive, and you get the same answer. Okay, number 4. Chebyshev's inequality. So Chebyshev's inequality says that the probability that capital X minus mu is greater than or equal to k is less than or equal to sigma squared over k squared. So that's what Chebyshev's inequality says. So therefore, the complement of this event, the chance that capital X minus mu in absolute value is less than k, that must be greater than or equal to 1 minus sigma squared over k squared. Okay, so in place of k, let me replace k by 2 sigma. So let's find the probability that x is within 2 sigma of mu, which is exactly the same thing as this here, except for the equal signs. This must be greater than or equal to 1 minus sigma squared over 2 sigma squared. And that simplifies to be equal to 0.75. So according to Chebyshev's inequality, that is the smallest possible value for this probability. Indeed, if we take a look back, that's larger than 0.975. This one was larger than 0.975. Sorry, I wrote this incorrectly. That's 4.5. I apologize. That's larger than 0.75, and that's larger than 0.75. So all of these answers are larger than 0.75, as expected by Chebyshev's inequality.